Solving by completing the square, just an optional extra with fractions involved. We want to solve this by completing the square. We need b over 2 all squared. b is negative 3 over 2 squared. That will give me 9 over 4. Remembering that a negative squared is positive, and we square out the top and bottom of the fraction separately. So x squared minus 3x plus 9 over 4, that's our perfect square, minus 9 over 4 plus 1 equals 0. Now, that means we factorize this as a perfect square, and we don't need to think about it because we know that it's negative 3 over 2 all squared. Minus 9 over 4 plus 1 means we've got negative 5 over 4 equals 0. Because of course 1 is 4 over 4, so we end up with negative 5 over 4. Now we have a difference of perfect squares. So I will want x minus 3 over 2 squared minus the square root of 5 over 4 all squared equals 0. Have a look at your fraction when I've got the square root of a fraction, because I can take the square root of 4 and write this as x minus 3 over 2 all squared minus square root of 5 on 2 squared. So if we can simplify, we do. Then of course, factorize as a difference of perfect squares. First term, second term, this will be my plus bracket. First term, second term, this will be my minus bracket, all equals 0. Then of course, give our solution. X minus 3 over 2 plus root 5 on 2 equals 0, or x minus 3 on 2 minus root 5 on 2 equals 0. And you can see that I can simplify these because I've got a common denominator. So x equals, I'm going to add 3 and subtract root 5 over 2, or x equals 3 plus root 5 on 2. And of course I can combine that if I want. X equals 3 plus or minus root 5 on 2. So a solution with some little tricky things with fractions in there, just as an example.